last session, we have seen IEEE 802.15.4, which is also called LRWPAN, and we have also seen about Wi-Fi. So today we are going to look at a networking technology, 6LoWPAN. So the abbreviation of 6LoWPAN is IP version 6 over low power wireless personal area networks. Okay, IP version 6 over low power wireless personal area networks, and it is a networking technology. So in the OSI model, or if you consider TCP/IP model, 6LoWPAN falls under networking layer. Okay, networking layer or network layer, right? So it provides an adaptation layer, okay, a set of functionalities which allow IPv6 packets to be carried efficiently within small link layer frames such as IEEE 802.15.4. So in the last session I told you that in IEEE 802.15.4 has functionality for physical layer as well as data link layer. Okay, it doesn't have any network layer. So we can use 6LoWPAN along with IEEE 802.15.4 to provide network layer functionality like routing. Okay, so 6LoWPAN is an open standard which is defined in RFC 6282 by an organization called Internet Engineering Task Force, IETF. Okay, so RFC means request for comments. So it's like a document. Its number is 6282. So in Google, if you search for RFC 6282, you will get the specification for 6LoWPAN. You can study about that. Okay, right. So it was this technology, that is 6LoWPAN, was originally developed for supporting IEEE 802.15.4 low power wireless networks in the frequency band 2.4 GHz. Okay, so it operates, 6LoWPAN operates on top of IEEE 802.15.4. So it was originally developed for providing routing functionality on top of this technology, IEEE 802.15.4. Okay, but nowadays it is being adopted for providing routing on top of smart Bluetooth, or you can say Bluetooth low energy, and on top of low power Wi-Fi and other technologies. Okay, right. So this is how a 6LoWPAN network that is connected to IP networks looks like. So this is your 6LoWPAN network. This is one IP network, and this is another IP network. Okay, so here this R thing is router, and these dark green things are hosts. Hosts means end devices. Okay, and among these three routers here, the rectangles, the middle one, this is connected to internet. Okay, right. And one more thing, this circle, this is a mesh network. Mesh is an example for topology. I think I mentioned this in the last session. Okay, some important points about that architecture we have seen. So the uplink to the internet, that is connection, is handled by a device called access point. So access point is basically a router. Okay, so it acts as a IP version 6 router, and we have hosts. They are devices which are connected to the access point, and those hosts can be either PCs, servers, mobiles, whatever it is. Okay, end devices. And the 6LoWPAN network, that is this thing, 6LoWPAN network, is connected to the IP version 6 network through an edge router. Okay, so this thing is called edge router. So don't worry about what is edge router. So router which is at the edge of the network is called edge router. So all the data from that network goes through the edge router. Okay, and data coming from internet to the network comes through the edge router. So it is the receiving point as well as transmission point for the entire network. Okay, right. And that edge router has three main functionalities or actions. So first one is the data exchange between the 6LoWPAN devices and the internet. Okay, sending and receiving the data between the 6LoWPAN devices and the internet is carried out by edge router. So second one, local data exchange between devices inside the 6LoWPAN network. That is this internal communication. Okay, is handled by edge router, and the communication between the 6LoWPAN network and the internet, that is also done by edge router. So you can see here it is also done by edge router. The communication passes through edge router. And third one, so the edge router has also the task of generating or creating and maintaining the subnet, that is the 6LoWPAN network. So if you remember in the last session, while I was talking about IEEE 802.15.4, I mentioned something called coordinator. Okay, so similar to that coordinator, here we have edge router. Okay, very similar. And some more points. So one 6LoWPAN network may be connected to other IP networks through one or more edge routers. So as shown in this example, how many edge routers we have? Here we have only one edge router. So it is not mandatory to have only one edge router, so you can have another one. Okay, and you can have the third edge router like that to connect different networks. Okay, right. And that connectivity to other IP networks can be provided through other technologies like Ethernet, that is wired connection, or through wireless connections like Wi-Fi or 3G technologies or 4G technologies. So the edge routers forward the datagrams at the network layer. So as I already told you, 6LoWPAN is a network layer technology. So the edge routers, that is 6LoWPAN edge routers, work at network layer. So that is why they do not have any application layer state. Okay, they do not maintain any application layer state. So the concept of sessions, etc., are not there in 6LoWPAN. We have to use other technologies for maintaining sessions and other functionality. Right. So there are two device types inside 6LoWPAN network. One is routers, another one is hosts. Okay. So routers will do routing. Okay, sending the data and receiving the data and giving it to the specific node. Okay, routers do routing. And hosts, as I already told you, they are called as they are nothing but end devices which wants to send the data or receive data. Okay, and these hosts are not able to route data. Routing is done by routers. Okay. Okay. One more thing, and host can be a sleepy device. For example, sensors. If you consider sensors in IoT, there is no need for sensors to be always turned on and send data. Maybe for, let's say, 1 minute the sensor will turn on and then send the data and again go to sleep. Okay, that is this. And why do they do that? For conserving the power. Okay, right. And now we will see the 6LoWPAN stack. Okay, in the next slide. But before that, let's see these things. So the development of 6LoWPAN has radically changed the IoT landscape. Okay. So before 6LoWPAN was developed, there is something called application layer gateway. It's a device for converting one technology to another technology. Okay, that is data produced by one technology into data that should be received by another technology. Okay, the device is called application layer gateway. So before 6LoWPAN, companies use these application layer gateways. Okay, so you can see what is the need of that was needed to make devices such as devices which are using Zigbee, Bluetooth, and other proprietary systems. There are others also like Z-Wave, wireless HART, etc. To make them connect to internet. Okay. For example, if I am using a Zigbee device, I have to use an application layer gateway to connect it to the internet. If I don't use any application layer gateway, then Zigbee cannot communicate with internet. Okay, send data to internet and receive data from internet. And 6LoWPAN solves this problem by introducing a new layer, that is adaptation layer, between the IP stacks, link and network layers. If you remember the TCP/IP model, at the bottom we have the link layer, on top of link layer we have network layer. So in between them, the 6LoWPAN introduces a new layer called adaptation layer. Okay, for transmitting IPv6 data over IEEE 802.15.4 radio links. So this is the stack. 6LoWPAN stack is on the right hand side, and they are comparing it with Wi-Fi stack as well as modified or simplified OSI model. If you remember, OSI model originally has 7 layers. So they have removed the 2 layers and they have simplified it into 5-layer model. So if you remember Wi-Fi has functionality of only 2 layers. One is physical layer as well as data link layer. So if you see here the 6LoWPAN, as I already told you, 6LoWPAN is built on top of IEEE 802.15.4 technology. Okay, so this is the IEEE 802.15.4 physical layer, and here we have MAC layer. So in between the link layer and the network layer, so this is the network layer, this is the network layer. between them, 6LoWPAN introduces a new layer. This is the adaptation layer we are seeing. Okay. So this allows devices which are using IEEE 802.15.4 technology to communicate with IP networks. Okay, because of this adaptation layer. So it is a set of functionality. We will discuss about that in the coming slides. Right. Now, some points about all these layers. Okay. So the responsibility of physical layer is to convert data bits into signals. Okay, analog signals. So those signals will be moving through air, that is wireless, or through Ethernet, wide connection, whatever it is. Okay. And the data link layer, its responsibility is to provide reliable link between the communicating nodes by providing error detection as well as error correction. Okay, that is when the bits are moving through air, maybe some bits might get lost. Okay, so such kind of things will be detected. Those things are called errors. So those errors will be detected, and again the data will be requested. Okay, right. And the data link layer also includes MAC layer, with media access layer, whose task is to provide access to the media. So the MAC layer includes functionality for how to access the medium. Okay, so we have different methods, TDMA, okay, FDMA, and all these things, SISMA. Okay, right. And the MAC layer also handles data framing, converting network layer packets into frames. And 6LoWPAN was originally designed for supporting IEEE 802.15.4. Okay, so as I have shown you in the previous slide, in the stack, the protocol stack, the 6LoWPAN adaptation layer, what does it do is it provides adaptation from IPv6, you can say conversion. Okay, conversion or modification or whatever, or transformation. So from IPv6 to IEEE 802.15.4. Okay, right. And on top of that adaptation layer, we will have network layer. Okay, so what is the task of network layer? Performs routing. Okay, so at the network layer, the protocol that will be used is Internet Protocol, or in short called IP. Okay, so the IP protocol will assign IP addresses to the devices for transferring and receiving packets. And on top of network layer, we have transport layer. So responsibility of transport layer is maintaining communication sessions. And finally, on top of transport layer, we have application layer, which is responsible for formatting data. Okay, so changing data from one format to another format, all these things will take place at application layer. And generally used application layer protocol is HTTP, which runs over TCP. So HTTP is application layer protocol and TCP is transport layer protocol. Okay, right. So as I told you, 6LoWPAN is a technology for converting, adopting IP version 6 to IEEE 802.15.4. Okay. And because of the resource constraints, we are talking about IoT. So IoT devices are resource constraint devices. Okay, and 6LoWPAN supports multi-hop topology. So what is single hop multi-hop means? Single hop means it requires only one hop to transmit the data to the destination. So the destination is only one hop away from the sender, and multi-hop means the destination is multiple hops away from the sender. So what is a hop means? It's a link. Okay. So this is single hop. Okay. And multi-hop means, so there are multiple stations in between the sender and the receiver. First hop, second hop, third hop. Okay, right. Because of the resource constraints and because of this multi-hop topology, there are several challenges. So what are the challenges? We have three here. 1, 2, 3. So first challenge is the IPv6 data or datagrams are not a natural fit for IEEE 802.15.4 networks. Why they are not a natural fit means because of low throughput and limited buffering, as well as the IP datagrams are datagrams, the IPv6 datagrams are 1/10 the size of the MTU header. Okay, so MTU means maximum transmission unit, and here they are talking about IEEE. Okay, I will directly point to it. IEEE 802.15.4. So what is the meaning of this is the data, the maximum size of data of a IP version 6 packet is far higher than the data that can be supported by IEEE 802.15.4. Okay, and the second challenge is this IEEE 802.15.4, as we have seen in the last session, it is both low power and it provides low throughput. So low throughput means because low throughput is the result of the data rate. So the data rate is less in case of IEEE 802.15.4. Okay, because of that the data is prone to interference. That means the data can be lost because of interference, radio wave interference. Okay, there can be link failures and there can be asymmetric links. And the third challenge is the common topology in 6LoWPAN is a low power mesh network. Okay, so why this is a challenge is, you can see here, the mesh topology, it negates the assumption that a link is a single broadcast domain. Okay, which is a normal thing in IPv6 networks. Okay, right. So these are the three challenges, and so while sending the data over MAC and physical layers, the 6LoWPAN adaptation layer is always used. Okay, now we are talking about the 6LoWPAN adaptation layer, and as I already told you, it was created by IETF, Internet Engineering Task Force. So the focus of that IETF working group is to optimize the transmission of IP version 6 packets over IEEE 802.15.4 networks. So they are also called low power and lossy networks, in short LLMs. So LLM means low power and lossy networks. So to perform that optimization of transmitting and receiving data, they have done three things. One is header compression, the IP version 6 header compression, fragmentation and reassembly, and also stateless auto configuration. Okay, so they have done these three things. So these three things are part of the adaptation layer. Okay, so I am not going into these details. So if you are interested in how the header is compressed, etc., you can search in Google. And now we are talking about routing. Now we are moving to the network layer on top of 6LoWPAN. Right. So what is routing? It is the ability to send data packet from one device to another device. Okay, either it can be single hop or sometimes it can be multiple hops. Okay, and depending on the layer where the routing is taking place, routing is classified into two types. One is mesh under routing, another one is route over routing. So mesh under routing uses link layer addresses. So link layer is layer 2 according to OSI model. Okay, so link layer addresses means so at link layer, what is the technology we are assuming? It is IEEE 802.15.4. Okay, we will use those MAC addresses or the short addresses, also called short address. In the yesterday session I told you 16-bit addresses are there, right? Okay, so that address will be used for forwarding data packets. That is mesh under routing. Now route over routing is layer 3, so it uses layer 3 addresses. Layer 3 is network layer. So at network layer we have IP protocol, so we have IP addresses. Now let's look at mesh under routing, some points about that. So the routing in mesh under routing is transparent, and all the devices in a mesh network are considered as one IP subnet, or simply saying one IP network. Okay, so you can assume mesh under routing as LAN routing, which takes place in a LAN, local area network. You can think of it like that. Okay, and there will be only one IP router in mesh under routing, and that router is the edge router, as we have seen in the previous slides. And the message have to be sent to all the devices in the network. So it's kind of broadcast. Okay, broadcasting means sending the same message to all the devices which are in the network. So what happens when the same message is sent to all the devices? It will result in high network load. The traffic will increase. Okay, so the scenario or application where you can use mesh under networks is they are best suitable for smaller and local networks. So as I already told you just now, to think of mesh under routing as LAN routing. LAN means local networks. Okay, so this is the mesh under routing. So source device, destination device, and what are these two stacks here is, let's say there is one intermediate system or device, and there is another intermediate system or device. In between the source and destination there are two devices. Okay, so you can see the data from the source is coming from application layer, it is moving down to physical layer, and from physical layer it will move to next device. On next device the data is going up to data link layer and again goes to the second device, again up to data link layer, and then finally it reaches destination, and finally the data reaches the application layer in the destination device. Okay, so this is layer 2 routing, also called mesh under routing. And the same thing, this is layer 3 routing. Okay, now it goes up to network layer in all the devices, and then finally at the destination it goes to the application layer. Okay, right. Now some points about the second type of routing, which is route over routing. So here the routing takes place at third layer, IP level. Okay, so each device that these things, each device means these intermediate devices. We are talking about these devices. So each hop or each device represents an IP router. Okay, and the layer 3, the most widely used or generally used routing protocol is RPL. Okay, it is pronounced as Ripple, or you can simply call RPL, or you can say Ripple. So the routing protocol which is used to route packets at layer 3 in 6LoWPAN technology is Ripple. So abbreviation is routing protocol for LLMs. So in the previous slides we have seen what is LLM, low power lossy networks. Okay, so this route over routing provides an advantage because it routes at layer 3, which is IP layer or internet protocol layer, and it is a part of the most widely used TCP/IP stack or TCP/IP model. Okay, and again this RPL supports two different routing modes. One is storing mode, another one is non-storing mode. So if you want further details about storing mode and non-storing mode, you can refer internet or search in Google. And finally, we will be talking about security. As we already know, IoT devices are resource constrained, and also there are more number of entry points. There are more number of entry points for an attacker. Okay, so what are the entry points means? We have so many sensors now. Each sensor is an entry point for an attacker. Similarly, we will have routers and all these things. We have mobile phones, laptops, and all these things. Every device is like an entry point for an attacker. Okay, and the damage potential is much larger or much higher in the IoT applications. Why? Because IoT applications will operate on things, right? So if an attacker is able to compromise the sensor on a door, the attacker can open the door, close the door as he or she likes. Okay, and also turn on or off alarms, whatever. Many things can be done. Okay. Now 6LoWPAN technology, as I already told you, it works on top of IEEE 802.10.4. This provides AES 128 algorithm. It's a, what we can say, let's say it is a method of security, a way of getting security. So it is used for encryption, encrypting and decrypting the data. Okay, so for for this they are using AES. AES means Advanced Encryption Standard, and 128 is the key size. So don't worry about all these things. So using this algorithm, they will provide the concept of encryption and decryption. Okay. So that link layer security will provide authentication. As I already told you, it also provides encryption. Okay. Right. That is at the link layer. Okay. To better understand this, so you have 6LoWPAN. Below that you have IEEE 802.15.4, right? On top of 6LoWPAN you will have TCP, UDP. They are protocols. They belong to the transport layer, and let's say the IP layer is here. Okay, IP. This is the IP layer. This is the link layer. This is the IP layer, and this is the transport layer. So 6LoWPAN, the data will be moving like this. Okay, at the sender. At the receiver, the data will be moving like this, from bottom to top, and at the center it goes from top to bottom, application layer to physical layer, and here physical layer to application layer. Now, as I already told you, here it uses 6LoWPAN uses the security which is provided by the bottom layer IEEE 802.15.4, and on top it uses the security from TCP layer, provided by TCP protocol or UDP protocol. So you can see here, in addition to link layer security, there is something called TLS, which is abbreviated to transport layer security. It is provided at transport layer. Okay, and for resource constrained devices, the transport layer protocol that will be used is UDP, and for this protocol there is another security mechanism called datagram transport layer security, DTLS. So for TCP it is TLS, transport layer security. For UDP it is DTLS, datagram transport layer security. Okay, so from that 6LoWPAN will have its security. However, it should be noted that implementing this TLS and DTLS specifications requires the device to have more amount of resources, such as hardware encryption engine. Okay, which might not be cost effective for IoT applications. So that is a kind of trade-off here. Okay, so that's it about 6LoWPAN. So let's quickly review what we have seen. So okay, we started from here. We have seen the abbreviation, and we have seen that it is a networking technology, and we have seen that it provides an adaptation layer for conversion between IPv6 to IEEE 802.15.4. And then we have seen the architecture, and we have seen some points about the architecture, and we have seen what are the responsibilities of edge router, and then we have seen the stack, 6LoWPAN stack, which is like this, and then we have seen about each layer on the stack, Then we have seen what are the challenges for conversion between IP version 6 to IEEE 802.15.4. And finally, we have seen what does the 6LoWPAN adaptation layer does. And then we have discussed about routing, how routing happens in 6LoWPAN network. Two types of routing, mesh under as well as route over routing. And then finally, we have seen the security of 6LoWPAN. Okay. So in the next session, we will look at ZigBee. Okay. That's it for this session.